The power is out, or maybe it isn't, and you just want the room to feel calm, so you light a candle, maybe two. Maybe you put one on every surface, because there's something about that small orange flicker that makes a space feel safe. But here's something almost nobody thinks about. Under the right conditions, that candle isn't just decoration. It is quietly filling your air with something you cannot see, cannot smell, and cannot feel arriving. No flame ever has to touch you, no fire has to spread. The danger isn't heat, it's a gas, and it builds in silence while you sleep or read or just sit there enjoying the light. And by the time your body notices something is wrong, it may already be too late to act. This is the story of carbon monoxide, of hemoglobin, of oxygen, and of a small dancing flame that has been quietly deceiving people for as long as fire has existed. This is the threshold your blood cannot negotiate with, and a danger hiding inside one of the most ordinary objects on Earth. But to understand how a candle turns dangerous, you first need to understand what a flame is actually doing, because most people think a candle just burns wax. It doesn't, not directly. The wick pulls liquid wax upward, heat vaporizes it, and it's that vapor, not the solid wax, that actually catches fire. What you're looking at when you look at a candle flame is a tiny controlled cloud of burning gas. And for that gas to burn cleanly, it needs one crucial ingredient in the right amount: oxygen. Give a flame enough oxygen and combustion is complete. The fuel converts almost entirely into carbon dioxide and water vapor, both something your body already handles every day. This is what happens when a candle burns in an open room with a normal supply of air. Clean, quiet, mostly harmless combustion. But take away that oxygen, even partially, the chemistry changes. When a flame doesn't get enough oxygen, it can't finish the job. Combustion becomes incomplete. Instead of converting fuel fully into carbon dioxide and water, the reaction stalls halfway, and it starts producing something else: soot, unburned particles, and a gas called carbon monoxide. And this isn't some obscure side effect. Miners used candles for this exact reason. Deep underground, air quality can shift fast, and a candle flame is remarkably sensitive to it. As oxygen levels drop, a flame changes shape. It shrinks, it dims, it turns a duller shade of orange, and eventually it goes out completely, usually somewhere around 16% oxygen in the air, compared to the roughly 21% we normally breathe. For a long time, that dying flame was the warning system. If the candle went out, you knew the air itself had become dangerous and it was time to leave. But here's the deeply counterintuitive part. By the time a candle flame struggles or dies from lack of oxygen, the air can already contain a buildup of carbon monoxide, a gas your own senses give you no warning about at all. No smell, no color, no taste. Unlike smoke, which stings your eyes and throat, carbon monoxide moves through a room and into your lungs completely undetected. The candle was never actually measuring the thing that could kill you. It was only measuring the oxygen, and by the time that number dropped low enough to matter, the far more dangerous number had already been climbing. So what is that number, and what does carbon monoxide actually do once it's inside you?
Here's what makes carbon monoxide so quietly lethal. Your blood carries oxygen using a molecule called hemoglobin, and hemoglobin is not picky. It will bind to whatever fits, and carbon monoxide fits extremely well. Carbon monoxide binds to hemoglobin roughly 200 to 250 times more strongly than oxygen does. Once it locks on, it doesn't let go easily, and it doesn't leave room for oxygen to attach in its place. So even while you are still breathing normally, still pulling in plenty of air, your blood is steadily losing its ability to actually carry oxygen to your organs and your brain. At low concentrations, this shows up as something almost nobody associates with danger: a mild headache, a little fatigue, maybe some dizziness, the kind of thing you'd blame on being tired or needing water. At around 400 parts per million in the air, headaches typically develop within a couple of hours. Push that concentration higher into the 800 to 1600 parts per million range, and confusion, nausea, and collapse can follow within an hour, sometimes less. Above 3,200 parts per million, unconsciousness and death can occur in under 30 minutes, and the cruelest part of this entire
entire process is that the people most affected are often the ones least able to notice it happening. You get drowsy, you get relaxed, and you fall asleep in an armchair, in a tent, in a small room, while the concentration keeps climbing around you, because carbon monoxide doesn't wake you up, it just makes you more tired. This is not a theoretical concern. This is documented repeatedly in enclosed spaces all over the world. Every year during storms, hurricanes, and winter power outages, emergency rooms see a predictable spike, not in burns, but in carbon monoxide poisoning. And candles are far from the only culprit. Generators and space heaters cause the majority of severe cases, but candles, especially in small, sealed, poorly ventilated spaces, have caused deaths on their own, and they show up again and again in the same kinds of places: tents, camper vans, small boat cabins, ice fishing shelters, anywhere people gather in a tight space, seal it up against cold or wind, and light a flame for warmth or light without leaving a way for fresh air to get in. Multiple documented cases exist of people in small sealed tents or vehicles who lit candles for warmth during cold nights and were later found unresponsive, with investigators tracing the cause to carbon monoxide accumulation from incomplete combustion in an unventilated space. The pattern is almost always the same: a small enclosed volume of air, a flame that's been burning for hours, and no airflow to replace what the flame is consuming and contaminating. This matters enormously when you think about who's actually at risk. It isn't people burning a candle in a large, drafty room with a window cracked open. It's people camping in sealed tents during cold weather. It's people riding out a power outage in a small apartment with the windows shut tight against a storm. It's people in vehicles, in cabins, in any space small enough that a single flame can meaningfully change the chemistry of the air inside it. And in almost every one of these cases, the people involved had no idea a candle could do this at all. So back to the flame in your room right now. The reason a candle can kill you isn't because candles are inherently dangerous. Burning one in a normal room with normal airflow is about as safe as anything in your home. The danger isn't the object, it's the conditions. Small, enclosed spaces, hours of burning, no ventilation, and it's exactly those conditions that people create without realizing it, especially when they're trying to stay warm or trying to keep light going during a blackout or a storm. We talk about fire safety, we talk about not leaving candles unattended, about keeping them away from curtains and paper. Almost nobody talks about air, about oxygen, about the invisible gas building quietly in a sealed tent or a shut-up room while the flame keeps burning exactly the way it's supposed to. The actual danger, the one that determines whether your blood can still carry oxygen where it needs to go, rarely makes it into the warning label. The honest, uncomfortable truth is this: a candle doesn't need to touch you to hurt you. It doesn't need to tip over or catch a curtain or start a fire at all. All it needs is a small, closed space, enough hours, and a lack of somewhere for fresh air to come in. And the next time you're lighting a candle in a tent, a small cabin, a sealed room during a storm, now you know what that quiet little flame is actually doing to the air around you, and why the thing you lit for comfort and warmth can, under the wrong conditions, be the thing that quietly takes it away.